which is probably not here so often in game dev, because I'm going to present something that has a hardware focus. And the title of this presentation is Painting Game Pieces with 3D Printers. And this connects to my game. That is called OI, das Satirespiel zur öffentlichen Infrastruktur. I'm going to be holding the talk in English. It could be that there's some things that I did not change from German, but if you have any questions, just ask me. So OI is a board game, which means that I will have to produce game pieces for that. And OI has been developed now for a year or so, and I'm currently in the phase where I'm packing up everything neatly to probably send to a publisher at some point. And one of the things that I was thinking about is these game pieces. And there's about 300 of them per game. And these are small. They are like a centimeter by a centimeter by a centimeter in size. And they're engraved, so you can have a look at them if you want. And the game mechanics is that you put them basically with the engraved side face down, so that you don't see them except when there's a game event that forces you to turn them around. And the problem is that they are a bit difficult to see. So you have to actually pick them up and look at them close, which takes a bit of time. Luxury problem, I know, but since I'm an engineer, that's unacceptable. So, potential solutions. You could make simpler symbols than the ones I did here. That would be a partial improvement, but not what I was really looking for. You could just leave one sort of these pieces unengraved, but that would be a pain to sort them back in the game box afterwards, because you would have to look at every single piece on all 6 sides to make sure there's really no engraving on there, so that's not really a solution. You could use an inkjet flatbed printer to make colored full symbols on top of there. I actually asked a few people if they would be willing to print them for me, but no one in Linz said yes, unfortunately. And there's absolutely no option to just hand paint them, because why would I spend just 2 hours doing that myself if I could spend 100 hours trying to automate the thing? And while I was designing my playfield, I was coming across an Inkscape feature that was called G-code tools, basically. And I'm not sure if any one of you is familiar with G-code. G-code is normally used as a form of communicating with CNC machines, may that be mills, cutters, 3D printers, etc. So they're basically text files that store positions for motors to drive to. And at this point, that got me thinking. And I was thinking, like, maybe I could use something like this to paint my game pieces. And I ran across the problem of Willhaben that is there all the time, that it's more expensive to buy second hand than it's to buy new. And in the end, I decided to try those 2 types of pens. Ballpoint pens are free as a student. But the problem is that they need a very precise force to actually draw somewhere, which is a bit unfortunate. Also, they're not so nice to paint directly on wood, because the roughness of the wood is different from paper, which makes it very difficult to get a consistent result from a ballpoint pen. But they are generally very sturdy. They don't die so easily, so that's their pros. With the felt tip pens, like this, they have a small felt tip where they have a relatively liquid ink, which is a bit difficult when you draw on surfaces that really suck the ink in. So it's difficult to get precise drawings with them. But on the other hand, they just draw under their own weight. So just you can just leave them falling down, and then they will draw perfectly. So that is nice. On the topic of mounting options, you can just use a 3D printed piece to mount the thing on a 3D printer. And lots of people have actually done that. The problem is all the solutions out there are really not that great. I tried a few of them. But what I wanted to do from this thing is that 3D printing should still be possible. So you don't block any air intakes, or you don't block any movements that the 3D printer would have to do. It should be a two-part design so that you can actually like change different pens in there. The force the pen should be subjected to should be adjustable. It should be supported relatively close to the tip, because I've tried some adjustment that just wobble a lot. Some of them also twist, which I also want to avoid. And one of the things that is also important is there's felt tip are actually quite easily to kill when you crash into them like this. So I wanted to have a force limit. When you have this two-part design with the tool changer, you put it in there, press it down, and with roughly the force you press it down, it will also come apart if you crash. So that's just to protect the pens. I can also throw this one if you want to have a look at that. So this is basically the design I came up with. Cool. I'm going to quickly show you how the process looks like, and then I'm going to do something that is always very difficult to do here, which is a live demo, and it will probably fail, but let's hope for the best. So we have a 3D printer here, where you can see on the side one of these things is attached. And my smartphone camera is really bad because I made a few interesting life decisions, and I'm now working in a laser lab, which is bad for CMOS sensors when there's super intensive nanosecond light everywhere. Here it is painting one of the exit meds on fire, which is the bad game piece in my game. And this is basically just controlled via USB from one of the computers. And in this video it's only one of them, but you can basically just have a whole grid that you set up with the cubes, with the original cubes, and then paint them one by one. I also have the cube here that I used for this demonstration. So to show you how that thing works, I'm not sure how familiar most of you are with Inkscape. Inkscape is generally just a 2D vector graphics design tool, basically. It's open source, and it's generally really nice, and as with so many open source tools, you sometimes have a little wonky things that just people put in there because it's fun. And one of the things that just is fun is the option to run G-code programming within Inkscape. And what we have here is the original graphics that I used for this game piece. And you should be aware that it is basically painting all the corners of this figure, even though, as you can see, the stroke is actually set to 0. So there's, if you would set the stroke to the defined size, it would paint the inner curve of the stroke, and it would paint the outer side of the curve. So that's a little weird, but be aware of that. And then what you want to do is position these graphics on the print bed of your printer. And you do that by just homing your 3D printer and then going to a specific point in the space, and you read the position from there, and then you run the G-code tools orientation points. In this case, I'm going to use 2-point mode. I hope the demonstration is not already failing at this point. Just taking a okay. That's a yeah. We'll see if it works. I've also prepared one file where it is already working, and the way we can set that up now is we have 2 points that basically give us the position on the print bed where I put these wooden cubes up there, and I want to tell the program on how those are orientated. So if it would be like this, I put a cube in here, and then go with the 3D printer such that the tip of my pen would be here. Get the position from there, and just set this position to here. For example, that could be in X direction. That could be like, for example, 40 millimeters, and in Y direction that could be 50 millimeters. And then I have a second position that is just 100 millimeters off to the left, so that would be 140 times 50. And then I'm going to take this whole thing, like I said, it's pretty weird that this actually works in Onshape, because this is something that you would not expect from a vector graphics editing tool. And then you run the, I just made it into English, so I have to quickly try that out, because I only know it German. I think it's tool library in English. Yes. You can run different CNC machining tools from G-code, and they need to know how the tool actually looks like. And in this case, I'm going to put in a cylinder that has 0.4 millimeters in diameter, because that's the size of the felt tip on the top here. So I'm going to put default. Yeah. I'm just going with the flow. Could be that it just corrupted, but anyway. And then I put it to the side. What you should be aware is that the diameter here is very important because it will not paint structures that are smaller than this diameter. It is actually smart enough to recognize that. So I have to change that to the actual diameter. And the workflow, as like I said, is super wonky because I'm now editing a vector graphics. To change some settings, which is a weird way to do stuff, but it works sometimes. Make sure to save the thing, and then you should select everything. Make sure that actually, like, this is selected, and all this is selected. And then I'm going to let run a script that is called path to G code. In this path to G code script, I'm going to also make sure that the actual heights are safe, so that it actually like goes 5 millimeters to the top if it is moving. I should also set that here, so that it doesn't crash when it just moves sideways. There's only an option that it crashes when it goes down. And then we're going to hit apply, and it's probably going to throw me an error. It is going to throw me multiple errors, which is nice.
I like that outlook.
Sorry?
I like that outlook on life.
Yeah, it is super wonky. But let's try if it actually worked. Could be that it worked even though it threw an error. I've also had that. Yeah, it generated a G-code file, which is nice. And the G-code file is actually there. So in this case, it worked even though it threw an error, which also sometimes happens. Be aware of that. So I will quickly show you what this thing looks like. So that is just a G-code viewer. And I will put the latest one, the one we just generated here, and hope it actually works. Yeah, and that seems good. So when I run the simulation, this is the path the pen is now taking on this 3D printer. And what you can then do is use a software. You could use Repetier. That is something that has been around when I started 3D printing, so like almost 10 years. But of course there's new software as well, where you connect to the USB port on your PC via a serial port basically, and then load the numerical G-code in here. And then yeah, I can do that because there's no printer currently connected, but then you would just hit print, and it's going to throw the text file that is on your PC via USB to the 3D printer and actually run this thing so that you can paint with this Flutter. Okay, so I think that was the most important part for this presentation. Da-da-da-da-dun. Ledger. And I'm going to this is just once more how you load this thing into Rappeteer and then drive this thing, and I'm going to end with a quote, and I'm open to questions. Thank you very much.
You should make a video about this. Like this whole presentation felt like one of those videos I would see on YouTube. Like, it might not be like, of course, it sounds like a very convoluted process, but the fact that you're really passionate about it just made it really enjoyable to listen to.
How many pieces have you already produced this week?
Like actually useful things?
Yeah.
One. Because I just got it to work last week.
Oh, okay.
Did you consider using a different material like art printer?
Sorry?
Did you consider making the pieces instead of wood or instead of resin?
I mean, I could, but the thing is just 400 pieces of those are €4 via your typical Chinese e-commerce site. And I also kind of like the feeling of having wooden game pieces, and I think there's so much plastic in board games anyway, so I kind of like this.
Consider a UV printer for printing the images.
I mean, I could, but I honestly don't want to. I have a resin printer at work also, but I just use it if I really have to, because it's like always a mess. And
But did you try a UV printer or did you ever consider that? Not a resin printer, but a UV printer.
a UV printer
Yes.
is
That's a printer that puts color onto a surface up to like 2 millimeters.
okay. But like inkjet thingy, so it actually sprays it on and then uses UV to cure it, or
Yes. It
okay.
uses UV rays to cure it,
Okay.
which is really fast.
Yeah, I don't have something like that, unfortunately. I asked a bit around with the like there's advertisement companies in Linz that say they print like company banners and stuff on wood, which I think with probably a technology like this, but they wouldn't print on these cubes that are stacked up like here, even that the surface is still relatively constant, but they said they couldn't do that, unfortunately.
Just
But-
topical of that because there's like a Kickstarter for a home machine
Okay,
UV printing from Aka.
that would actually be great. So if we could talk about that,
I can show
that
you
would be
one if you want to.
yeah, would be nice. Would be nice.
One more question.
Yeah.
Like when you pitch this to publishers, of course, and such, regarding the having wooden blocks, do you think it would change the price of the game much if you go for wooden pieces versus just massively produced plastic ones?
I mean, injection molded and wooden pieces is roughly the same price.
Ah, that's good.
There's like you could also use acrylic ones that are then a bit more expensive.
The deluxe
Um,
edition.
Sorry?
The deluxe edition, basically.
Yeah, probably. Probably. But yeah, that is definitely an issue because the game is like relatively simple. So it's aimed at families and there's a party game and so on. You can basically like build 15 or 20 euros for that. So it gets a bit difficult to actually produce all the game material that you need for that. So yeah, as a publisher, of course, you're going to make this in a factory. I'm going to just use this process so that I can have some nice pieces while pitching the thing. Yeah.
So you're using these cubes because you can buy them cheap, but have you considered using a large piece, print everything and then cut it up,
Yes. Yes.
and that's not working, or?
I just never tried it. Like I know it would be an option, and probably the the people who said they wouldn't print like this thing would be able to engrave that thing, but then I would have to search for someone who actually cuts this, which basically like shifts the problem from searching for someone who prints this to someone who cuts this. So
Probably
yeah.
the easier one.
I'm not sure. Honestly, I don't know. Could be.
But you need to treat wood afterwards, right? You need to cover it with some kind of lackierung. So it should be some like oil or anything after that, just to prevent from moisture penetrating it and stuff like this.
I mean,
How
the,
it
I mean,
works
I mean,
in
this wood is only going to be used indoor,
Yeah.
and moisture is not such a big problem, and it's a prototype.
Mhm.
But generally, I agree with you. Also, when you buy these wooden play pieces in a
Mhm.
board game, they always have some lacquer on
Yeah,
them,
yeah.
which in fact would even be better in this case, because as you see with the one piece I put around, since the wood actually absorbs the ink
Mhm.
that is in there, um, the ink pattern is spreading a little bit, and if you would have a lacquer on top of that, that would be great to keep the ink on the place where you deposited it, and it would make for a sharper image. So would be nice if you would get pre-coated of those things, but I've not found a vendor that is going to sell that to me for a reasonable price yet.
Have you tried gel pens, maybe?
I've also tried like blue gel pens. This did work really great on paper, but they had a lot of problems with this one. But it could just be that it was the specific kind of gel pen that I used.
Because I thought it would be spread a little bit less ink because
Yes,
it's not so
it would like the ink is more viscous with the gel pen, which would help with the spreading inside the material. But the problem is that with the gel pens you have basically a tiny metal rod,
Yeah.
and the ink is sucked in there and then deposited from there, and this metal rod first can bend under stress, so it's also a bit more tricky to get the right amount of force to get them to paint, and if there's too little force, they also don't paint at all.
Yeah.
So
Yeah.
they're
of
they're
course.
they're 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 a bit difficult to handle, but yeah, they would make for a better image. Yes. Okay. Any more questions? Then I think we're going to change to the next speaker. Very much.